Hi everybody, Mrs. Danielson here, and today we're going to take some of those trig functions we've been working on for the last couple of videos, and we're going to actually apply those to some story problems or some real life problems that we might get down the road. So let's go ahead and get going on those guys and see where we're headed and actually have some fun applying the things that we've been working on. Okay, so let's go ahead and move over here to my iPad. I've got some things set up and ready to go. The first thing we're going to work on today is actually solving a triangle. So what does this solve a triangle? What does that mean? Solving a triangle means to solve for everything in the triangle. All three sides, all three angles. All six of those things are solved for. If you get a problem that says solve the triangle and you haven't done all six things, then it's not completely solved. So here's a triangle, and the way we generally label these, or the default, is that the angles are labeled with capital letters. So this would be angle A, for instance. I could label it anything, but capital letter A, capital B, capital C, my three angles. And then the sides opposite those angles are the same letter but lowercase. So like opposite angle A would be side A, and opposite angle B would be side B, opposite angle C, side C. So three angles, three sides. And for the problem to be completely finished, all six of those things need to be solved for. Okay, so this is just a problem we're going to say solve the triangle, meaning everything has an answer. Okay, so for this problem, let's say we're given a couple of things, right? First of all, we already know one of the angles, right? Angle C is 90 degrees. We already know that one. And let's say we're given angle A and it's 30 degrees. Okay, so we have two angles already. And let's say that side C, we're given that and it's 12. Okay, so what we need to find out to solve this triangle is we're going to need to know angle B, and we're going to have to figure out side B and side A. Okay, well, one of those things is pretty easy to figure out right off the bat, and that's angle B. Angle B we know because a triangle adds up to 180 degrees, and we already know two of the angles, right? So angle B is just going to be whatever is left over from 180 when I subtract the other two angles, right? So 180 minus 120 degrees, the leftovers would be 60 degrees. So that's going to be my angle B. Okay, so that one's pretty easy to do. Let's go ahead and put that in there. Right, we figured that one out. Angle B is 60 degrees. We're on our way. Okay, now we need to figure out side A and side B. And for that, we're going to use some of the trig that we've been working on the last few videos. Okay, so let's use that 30-degree angle we were given at the beginning. And we know that the sine is opposite over hypotenuse. So the sine of 30 degrees is opposite, and opposite that 30-degree angle is A. And the hypotenuse for this one is 12. Okay, so to solve for A, I just need to move that 12 over to the other side, right? So if I just rewrite that a little bit, I would get that A is equal to 12 times the sine of 30 degrees. Okay, and the sine of 30 degrees we solved in that last video, and it's 1/2. So it'd be 12 times 1/2, or 6. So A is 6. Okay, excellent. Not too bad. Okay, that just leaves us with side B. Okay, and for side B, I still want to use that 30-degree angle, although you could, if you wanted to, you could use the 60-degree angle as well and just use a different trig function. You have lots of options here. But let's stick with that 30-degree angle. And now I want to use cosine instead because I'm solving for B, which is adjacent. Okay, so I would do cosine of 30 degrees is adjacent, which is B over 12, hypotenuse. Just rearrange that 12, move it to the other side, so B is by itself. And you would have B equals 12 cosine 30 degrees. And the cosine of 30 degrees we got in that last video, and we put on that table for you to use, and it was the square root of 3 over 2. Okay, so that simplifies to 6 square root of 3. Right, so if we want, we can come up here and put that on our triangle, 6 square root of 3, and that triangle is completely solved now. All right, we just used a couple trig functions, a little bit of knowledge about a triangle, and we were good to go. Okay, so what we're gonna do now is we're gonna put another one up here, and then you guys are going to take a minute and you're gonna solve it on your own. You're gonna push pause on your video. You're gonna come up with the answers, and then we're gonna compare and see if everybody got the same thing. Okay, so we have a triangle here, and again, we're gonna stick with that 30-degree angle because that's what we're best at right now, 30, 60, 90, and 45, 45, 90, right? And we're gonna have side B and side A. That's what you're gonna be solving for, and angle B, and your hypotenuse is 14. Okay, you're solving that triangle. So you need to solve for angle B and sides A and B. Okay, go ahead and pause the video and then push play when you've got the answers. Okay, got the answers. Let's see how we all did, if we got the same things. Okay, just like in the last video, angle B is pretty easy to solve for when it's the third angle in a triangle and you've been given 2, right? It's gonna be 180 degrees minus 90 minus 30. The leftovers in this case, again, are 60 degrees. So angle B is 60. Okay, all right. Now we need to find A and we need to find B. Okay, and you have different ways you could go about doing this. You could use the 30-degree angle. You could use the 60-degree angle. You could use sine, cosine, tangent. Lots of ways to go about doing it. Just because I'm doing it here using sine of 30 does not mean it's the only way to go. You could use other ways as well, or other ratios. But we're going to use sine of 30 degrees here. Sine is opposite over hypotenuse. Opposite is A. Hypotenuse is 14. Okay, just rearranging our terms there gives us A equals 14 sine 30 degrees. And the sine of 30 degrees is 1/2, giving us that A equals 7. I hope that's what everybody got, a 7 there on A. Let me go ahead and put that in there. Okay, and it should look right. I mean, right, 7, the side opposite the 30-degree angle, it should be shorter than the hypotenuse. It should look good size-wise. Okay, now let's do our cosine of 30. Right, so that's going to be adjacent, which is the B. Okay, so B over 14. Just rearrange your terms there. Solving for B would be 14 cosine 30 degrees. And the cosine of 30 degrees is the square root of 3 over 2. And again, eventually, if you don't know them now, you're going to get to know those pretty well because we use them quite a bit. But for now, if you need to check your table or whatever to find that, that's okay. Okay, so B equals 7 square root of 3. Okay, so right here, 7 square root of 3. Okay, hopefully that's what everybody got, and we're feeling like pretty confident with being able to solve a right triangle. Find all 3 angles, all 3 sides. Okay, the second kind of problem we're going to work on today is just more of an example of like a right triangle you'd find out in the world. Okay, so for instance, if we had like a giant redwood tree, and you're going to have to bear with me as I try to do some drawing. We have a giant redwood tree that casts a shadow. 532 feet long. And we want to find the height of the tree if the angle of elevation of the sun is 25.7 degrees. Okay, so for problems like this, it always helps me to like draw a picture, even if it's not fabulous, but like to draw a sketch or something, just kind of visualize what the problem is, right? So in this case, what we're saying is, okay, we're going to draw a little tree. Bear with me with my art here, but we're going to draw a little tree. This is my giant redwood tree. Okay, and there's a shadow on the ground of this tree, right? We have a tree shadow on the ground here. Okay, that's being cast by the sun, right? The sun is behind the tree and it's making a shadow. Okay. Oh, that is not a good straight line. Let's try that one again. All right, there we go. All right, there's my attempt at a drawing. Okay, but it helps me see what's going on. Okay, so the angle of elevation to the sun is 25.7 degrees. Okay, and the length of that shadow is 532 feet. And they want us to find the height of the tree. How tall is this tree? Right? That's our unknown. The height of the tree. We'll call it h. Okay, so we're going to use our trig functions to help us find that. Okay, we know the angle. And what two sides of this triangle do we know? We know the adjacent side, that's the shadow. It's adjacent to the 25.7 degree angle. And we want to know the opposite side. That height is opposite the angle. So what trig function uses opposite and adjacent? It's tangent, TOA, right? So we're going to use tangent to solve for the height of this tree, right? So it's going to be set up like this. Tangent of 25.7 degrees is opposite, which is our h, over 532. And then you're just going to solve this for h. It's that simple, right? It's just going to be 532 times the tangent of 25.7 degrees equals h. Now, 25.7 is obviously not one that was one of our special triangles. It's not a 30 or a 60 or a 45 degree angle. So for this one, you're going to use your calculator to solve it, right? So you're just going to put in there 25.7 degrees tangent, and then multiply that result by 532, right? And you are going to get for h approximately 256 feet. And that is the height of your tree. You know, this is an application problem. So the best way to wrap up your answer is to actually explain it. So the height of the tree is approximately 256 feet. By wrapping it up with a sentence at the end, just shows your teacher or the person you're explaining it to that you actually understood what you were solving for in the problem. Okay, so this shows me, I know I was solving for the height of the tree, and it's 256 feet. Okay, so it's a nice little application problem. Okay, let's do one more like that, shall we? Let's say instead, well, let's have you guys solve one where instead the shadow of the tree is 452 feet long. And the angle of elevation to the sun is 12.3 degrees. Now how tall is the tree? Okay, so you're going to pause the video, solve for the height of the tree. And once you get that answer, then you'll push play again. All right, you get an answer? Let's see how you did, right? Very similar problem to the last one, right? We have our tree. We want to know how tall it is. We have the sun up here and a shadow of the tree. But our angle of elevation this time is only 12.3 degrees. Okay, and our shadow's height is, how long is it? 452 feet. Okay, just like on the last one, we're working with opposite and adjacent. Opposite and adjacent are tangent. So it's going to be tangent of 12.3 degrees is opposite over adjacent over 452. Okay, so your height is 452 times the tangent of 12.3 degrees. Just put that in your calculator, the tangent of 12.3, enter, times 452, and you should get, what should you get? You should get 98.55, about that, in that range. Okay, and then wrap it up with a pretty sentence. The height of the tree is approximately 98.6 feet, something like that, in that range. All right. We just have one more thing I need to talk to you about today. And that's, what if we're not solving for a side, but instead we're solving for an angle? How do we do that exactly? It's a little different how we use our calculator, right? So let's just combine that with an application problem. Okay, so let's say we have a 40-foot ladder. Leans against a building. And the base of the ladder is 6 feet from the base of the building. What is the angle formed by the ladder and the building? Okay, so what is it we're talking about here exactly? Right, we have a building. This is my building, some windows. We have a ladder leaning against the building. Here's my ladder. Okay, what do we know? Well, we know this ladder here is 40 feet long. And we know the base of the ladder is 6 feet from the base of the building. So this right here, this is 6 feet. And what we want to know is we want to know this angle right here. What is the angle where the ladder meets the building? So we're solving for an angle here instead of a side length, which is a little different than the last couple of problems. We're still going to use our trig ratio to help us solve for it, but we're going to use our calculators a little different this time. Okay, so which trig function are we going to use to solve for that angle? Well, the sides that are involved here are opposite and hypotenuse, and the trig function that uses opposite and hypotenuse is sine, right? So it's going to be sine of that angle is opposite over hypotenuse, and opposite is 6, and hypotenuse is 40. Okay, 6 divided by 40 is 0.15. So we know the sine of that angle is 0.15. Okay, so what you're going to do is you're going to put in your calculator 0.15, and then you're going to use inverse sine. You have a little inverse sine, looks like that on your calculator. Okay, so you do 0.15 and then inverse sine. That's actually going to give you the angle that has a sine of 0.15. What angle has a sine of 0.15? Well, if you use that button, it's going to tell you that the angle is approximately 8.6 degrees. Okay, did it work? Okay, if you have an older calculator, it might not be that button. You may have to use an inverse sine button, or you may have to use an arc sine button. Every calculator is a little different. They're all kind of different, but one of those three should get you to what you need to do to find the angle instead of the side length. Okay, all right. That's it for today. Thanks for joining me. Everybody have an incredible day today. It's been terrific. Bye.